Hello, my name is Nyasha Gandawa. I am a sophomore in the McDonald School of Business. I come from Harare, and my majors in the McDonald School of Business are Finance and Operations and Information Management. The title of this research project is Factors of Production, Interpretation of Renewable Energy Policy. My research advisor for this project was Professor Robin Dillon-Merrill from the McDonald School of Business. And this research project goes into computable general equilibrium modeling, which is a tool that economists use to simulate conditions of an economy when a new hypothetical policy is introduced to the economy. And what we did was we used this tool on not California's economy per se, but California's electricity sector alone, and treated it as though it were an entire economy on its own with self-sufficient means of production, as well as exhaustive consumption in that economy, hypothetical economy. And what we know from California is that it uses a diverse set of policy instruments that it uses to penalize carbon emissions, such as renewable portfolio standards, such as carbon emissions trading schemes and carbon pricing. But we simplified all of these policies into one Pigouvian tax on the economy. And this was supposed to represent a penalty on carbon emitting sources of electricity in the electricity sector in California. As for CGE modeling, we have a statistical base that we use to create a CGE model that is known as a social accounting matrix. It is a list of receipts and expenditures in the economy. That is the image that we see on the top left corner. On the bottom right corner, we have the image of the CGE model in Excel, and the application used to create this model. This particular model was Excel Visual Basic for application. We considered two factors of production, or two types of factors of production. These are capital inputs and technology factor inputs. And we say that these are exhaustive of all types of inputs that may be used to generate electricity. And we also considered two exhaustive types of output: renewable electricity and non-renewable electricity. And we respected the neoclassical assumptions of economics, that is optimizing behavior in market participants, cost minimizing, profit maximizing, and utility maximizing on behalf of both consumers and producers. These components of the economy are related to one another via the functions that allow these optimizing conditions. These are the cost functions, the production functions, the utility functions for consumers and producers in the economy. And to simplify all of these, we have a schematic representation of the entire economy. As we can see, we have a tax rate in the economy, and upward changes in any component of the economy is shown by green arrows, and downward change shown by red arrows in the economy. Now, as for results, what we did was we followed the relationship, or the ratio between the amount of resources allocated in renewable sections of the economy versus non-renewable sections of the economy for both capital factor of production and technology factors of production. And when we have an aggregate of the two factors of production, we get the total production in the economy, that is the value added by renewables and non-renewables. And what we have is a general increase in the relative amount of resources allocated to the renewable sections of the economy, as opposed to the non-renewable sections of the economy, as the tax rate increases on the horizontal plane. To conclude the entire research project, we have three points that we should iterate. One is that when policy targets the cost of production by non-renewable sources of energy, this allows renewable technologies to replace these old non-renewable technologies because they become relatively cheaper. The second is that when drafting policy for the environment, we should be guided both by the impact of the policy on the behavior of market participants, consumers, and producers, but also by the impact of the policy on how resources will be distributed in the economy, that is capital, technology, labor, etc. And the last piece of conclusion is that we should collect more data on the influence of technology in the production process, because what we have is traditional economics analysis that use labor as a primary factor of production, but transitioning to one that uses technology will be useful because it reflects what we have status quo, which is a need for more innovation and technology in order to solve this environmental crisis that we face currently. And to conclude this entire presentation, I would like to give my thanks to Dean Grant and the McDonald School of Business for making this research fellowship possible. I'd like to thank Dean Brancaforte and Dean Armani for their support, their overwhelming support, and making all of this possible. I'd like to thank my faculty advisor, Professor Robin Dillon-Merrill, for her insightful advice, for her commitment to the learning process, and much thanks to everybody for watching this. Thank you.